welcome everybody to the next MAIA webinar. It's quite impressive that 100 people registered for this webinar. It's really great. I think it shows the interest in the overall field of accounting, and also that with the MAIA project we're able to make at least a small contribution to advancing ecosystem accounting. This is already the 8th or the 9th, depending on how you count, webinar of MAIA. And also this webinar will be recorded, right? So yeah, be aware of that. That when you ask questions, those will be recorded as well. I'm not going to give a very long update on the MAIA project because this is not the first webinar. So many of you have also joined other webinars. Also, we had our stakeholder workshop just last week, which gave a comprehensive update of the MAIA project, but just a few very small points. So the first, of course, is that all the information on the webinars you can find on our website, right, maiaportal.eu, and there you'll find the recordings of the webinars. You'll also find fact sheets on progress in implementing ecosystem accounting in EU countries, and you also find links to all kind of publications and published accounts. So it's becoming really a nice source of information, I think. Then what I would also like to update you about, that we have one more webinar before the summer, the European summer, and that's on hydrological ecosystem services, accounting for those, and also sea water, which will be on 21st of June in the morning, also European time. So already be informed of that. Put it in your calendar if you're interested. I think another small point I would like to mention is that we are also progressing in the MAIA project work on the viewer, on our web tool. And at the moment, we're still updating that. At the moment, we're working on better accounting for changes in time. So we're putting information for different years in there, and also see then how you can use those those maps from different years to produce accounting tables. And I think we should be able to kind of make that more broadly available after the European summer, so September, I hope. And maybe we'll organize a specific session also on that to introduce people to the viewer and the tools that it has. And all the data sets that are in there. I think that's my update. There's not so much more I wanted to say at this point on the MAIA project. I really look forward to this wonderful webinar as well with all the speakers. You'll see that the presentations are relatively short, so you have a real nice diversity of presentations. And many thanks for all the speakers also for making yourself available to present in this webinar. Many of the speakers are from the MAIA project, but also we have speakers from outside that have been so kind as to deliver a presentation. Of course, as always, we have a discussion in the end. The moderator, Lisa, asked me to remind you that if you have any questions, please put them in the chat box, and then those questions will be discussed in the discussion section at the end of the webinar. So I think, and I already informed you that I wouldn't take the 15 minutes that was planned, because I think it's better to use our time for the contents and for discussing the marine accounting. So I think, Tinju, I already give the floor to you, because this was really all I had to say on the MAIA project, unless anybody has a specific question on this. And then this is the time. And otherwise, I think I've already talked enough for today, and I really look forward to the presentations. Tinju, what I should say, of course, by the way, that I'm very proud actually of the first speaker, because Tinju was my master's student. I think 6 years ago, Tinju, was it? And then you went to Finland to work on your PhD. So it's really, very nice as a teacher at the university, of course, to find your master's students back and really involved in the work as well. So your presentation, I really look with double attention, I must say. So good luck with all that.
Okay, yes, as I say, thank you very much to invite me to give this presentation. I'm from working in Finnish Environmental Institute in Suke, and from a Marine Research Center. Today's presentation is prepared together with Lisa. So but I'm the main presenter for this following 15 minutes. Before we formally go into the challenges of the marine accounting, I would like to briefly introduce some marine accounting related project in Phuket, so it will be more easy for you to go into when I go into the challenge. In Phuket, there are 3 asset projects until now. Not all of them are. They are cover also other accounting for other ecosystem type, but one of the focus related to the marine accounting is focusing on the accounting of fisheries resources. We consider the food web interaction and also including recreational fishing. And in the first 2 projects that we focus on the methodology and also valuation for recreational fishing, but in the currently ongoing project, we try to pilot a comprehensive account cover fish resources, including commercial and recreation and inland and marine water and the marine ecosystem of fish, and cover pilot supply and use account and asset account. And the following 2 projects are not directly compile marine related accounts, but they are relevant. The MAIA 1 project are focused on the valuation of ecosystem services, but try to follow the recommendation from MAIA and evaluate the valuation method and existing data. And in that project, we focus on several services to provide from different marine habitat, including the common reed for bioenergy, ferromanganese, which is abiotic services, climate regulation, water quality control, and oil waste decomposition, and recreational services provided by different marine ecosystem type. And the next project is following the continued work from MAIA 1 project, the valuation from this kind of different ecosystem services, and focusing also on the trade-off of service and feedback. The thing is, because we try to follow the recommendation during the valuation, and so the challenge we face, it will also happen if we want to further compile to the marine account. Also another project, the MAIA project, I won't mention here because the next presentation will introduce more about this project. And for the challenge, for the presentation of the challenge about marine accounting today, the most challenging I will present here is based on the experience of our project. So some of the challenge might not necessarily happen for other country or other case, but here we can share our experience. And based on our experience, the main challenges are related to data, variety kind of data issue, including lack of data, mismatch of data. For example, different biophysics unit in different stage of compile account, and this unit mismatch also between the ecological assessment and also the valuation study. Another issue we face is also not all valuation methods applicable to accounting, and also have a special scaling issue. And in the following few slides, I will go more in detail by the type of services and with some general challenge for marine accounting. And as I mentioned, one of the focus of one of our projects is fish accounting for fish resources. As most people probably already know that the supply and use account is very straightforward. So the challenges mainly happen in these 2 types. One is linkage to the habitat extent and ecosystem account, and the other one is related to compile the monetary asset account. About the linkage to the habitat and ecosystem condition account is based because of the characteristic of the fish migration and different age of group of fish will live in different habitats. So this increased the challenge to assess the contribution of nursery, feeding, and other functions from specific habitat and the condition to fish stock and and then they're linked to services. And for the monetary asset account, what we face is because we would like to consider food web interaction and this different kind of services related to fish. So this the trade-off of different services and this interaction need to have challenges in predict the expected services when we want to compile the monetary asset account, and because quite often a suitable bioeconomic model is not suitable for all kind of species, and this kind of challenge is probably also likely happen for other kind of services when you want to predict the expected services, especially when multiple services will like to consider, will like to include it in the ecosystem asset count. And also another challenge is how to assume the policy for the future ecosystem services use is also one of the challenges that we have faced. And for the regulating services, as I mentioned, they are quite relevant, quite often relevant to the data. And there's one characteristic is the map type of the ecosystem extent. Unlike the terrestrial ecosystem, that the ecosystem extent is more easy to identify, for example, by the satellite. Getting this extent data from marine is more difficult, and quite often they have different type of map types. For example, in our experience, we have some map types are collected. The collected map types are in the probability of the habitat appearance, and also other type of map is show in the density of specific species, and different kind of habitat has issue of overlap. So this brings us difficult when we want to further establish compile the data from estimate the services from this extent provided by extent to the valuation. And because during this process we collect the data from for extent and condition and services from different sources, and this created this mismatch of data, especially in the unit. And this is probably this kind of mismatch issue is quite easy to happen, and it would be better that it will require a well plan in advance, that which kind of data and the unit that require well plan in advance. Otherwise, in the later stage, when you want to value the services, then the value cannot evaluate comprehensive because of this kind of unit in the physical stage are already mismatched. Another issue that we quite often face for the regulating services is the data availability in the physical unit, especially at the ecosystem type level. In the case of Baltic Sea, we can see that some of this, for example, the services of water quality control is possible to estimate as whole Baltic Sea level with some existing data. But when you scale down to the ecosystem type level, this kind of estimate this kind of data are quite often lack, and without this physical unit data, the valuation is also not possible. And for the cultural services, we have some experience for recreational fishing and other recreational services. For the recreational fishing, because this compiled recreational fish is together with the commercial fish, and it's very easy to compare that that recreational fishes have less regulatory statistics, that unlike the commercial fishes, they can easily get the data. But also same for the commercial fishery, that the linkage for this recreational fish services to the habitat is also not so obvious. And for other recreational services, that we have an example from swimming chip, that is one of the characteristics that most not all, but many of the recreational services more often happen in the coastal area. So they're linked to function. They are linked to the function condition, and also then further linked to the habitat is also hard to establish. And in the case of if, for example, if we want to use the travel cost model to value the swimming trip, there are only few models that really include the effects of ecosystem condition to the behavior change. And even if they are, even if this kind of condition, ecosystem condition are already including the travel cost model, there are also some issues that the indicators used probably not completely match with the indicators that used for the ecological study, that which more typically used for compile the condition account. In addition to those challenges that we have faces, there are also some more general issues that probably that may apply to marine accounting in general. And one is the scope issue that the mismatch of ecosystem scope and the national scope that used for national accounting, that should be cover the exclusive economic zone. As I mentioned, the fish migration is an issue, but also some other ecosystem condition indicators, like the level of nutrition and hazardous substances, also don't have clear boundaries. So the ecosystem services provided by the habitat are also to control this substance also have effect across the boundary that was across the boundary for the accounting. And another issue is the three-dimension characteristic of the environment. There are many ecosystem condition indicators will be different in the deepness. And so in our previous experience, we are not really dealing with this, but this has happened. It exists. That should also be considered. And another issue that need to consider is about how to link the pressure and feedback from the specific use of ecosystem service back to the extent and condition. And we have this is more based on our ongoing project, that we have some assumption case of common reef provided for bioenergy and mining for potential ferromanganese concretion from the pilot case we had, but then we can use some assumption case, but there are how this activity have feedback back to the condition is things that we are still dealing with. And this is concerned because for that project we also try to follow use the result of accounting for this kind of special planning, and this cannot be directly dealing with the case we have now. But some of these issues, like the scope and how to define the extent and condition account, will be mentioned, and in the next presentation. So here I just briefly introduce some the challenge from very many kind of perspectives. But I think in the next presentation, you probably can see some of the solution already exist. And yes, it's the end of my presentation.
Thank you very much. Thanks for Tinyu for an excellent presentation of challenges. And she mentioned I'm addressing a few of them. And necessarily our approach is defined by our background. Myself, I'm a marine ecologist, and Elina, my colleague, who has prepared most of the analysis and slides for this presentation, is a geographer by education, and this, of course, kind of determines how we see marine accounting and how we try to solve it. MAIA has been an extremely interesting experience and project in the sense that brings together people and scientists from different backgrounds, and I have been learning a lot from my socio-economic and societal colleagues during the project. So what I'm showing here is a strictly spatial approach to ecosystem accounting in marine areas of Finland. I'm just trying to figure out how to define extent of ecosystem in terms of key species and habitats, and how to determine the condition of the environment and how to take these into account in assessing or providing background for estimates of the benefits that the marine ecosystem can provide to humans. One of our challenges that Tinyu actually did not mention is the extremely complex archipelago areas where a large part of our ecosystem services actually take place. These are just two pictures of our very scattered islands and skerries and different types of embayments. For those who are not so familiar, I'm going to fly from the space towards our sea area. This is Finland and its coastal area. We fly down closer. We can see very complex archipelago coming up. Still zoom in. It's more and more complex, and I challenge anybody to find a more complex environment physically in the entire world. So this makes it rather challenging to make any inventories of the habitats and ecosystem service laden areas. So going down to the earth level, you can see what it could look like. Here is a road crossing the archipelago, and on both sides of the road there might be different types of habitats, and they are varying in the scale of meters and tens of meters rather than kilometers or wider areas. So to solve this type of challenge, we have an inventory program that has from 2004 collected observations of underwater habitats and communities and species from more than 160,000 places, and from all these we have information of the habitat type, whether it be rocky bottom or muddy sediment or mixed sediment type or sand, and also information on the main species living on the substrate. And in addition, we have more detailed observations of the species done by diving. These 160,000 observations have been mostly made with underwater videos. Also, we have a lot of data on human activities. 100,000 sites identified where anthropogenic pressures take place, different types. You can guess what this is. White is land and gray is sea. And you can see that all the coast is dotted by red dots, and each of these are actually small dredgings due to the summer cottages and their fairways, minor fairways, etc. So you can imagine how much disturbance this type of activities will be causing to the environment in the such inner archipelago areas. So we take a spatial approach, marine accounting. First, as usual, define extent of the ecosystem, then determine the condition of the ecosystem, and use these two to assess the capacity of habitats, species to supply benefits for humans. So the first step is the extent, and we are using a spatial distribution modeling of species and habitats using these 160,000 observations, and that gives us models that have a spatial resolution of 20 meters throughout the entire Finnish coastal area. The next step and the problem will be how to estimate the extent of habitats in good condition, because we can assume that these are the ones that are providing us the benefits and the ecosystem services that can be later assessed. This will be done by assessing areas that are firstly severely degraded or completely lost, and secondly mildly or more severely disturbed but not totally degraded. So the first one would be from the information and GIS data we have to look at the disturbed or degraded habitats in the coastline. This is capital city area of Helsinki, and yellow areas would be areas that are totally or almost totally lost due to the activities taking place on the shores of the capital city. And this, of course, is one of the most severely used and degraded areas in all of Finland. Other areas might be much more pristine. So now we have this yellow area, and part of this yellow area is overlapping habitats. And here you see a calculation on the first column, total sea area of Finland, about 80,000 square kilometers. And then we also have data for the EU habitats of the directive Annex 1 habitats, and that is more than 5,000 square kilometers, which is almost 7% of the total sea area. This would be reefs, lagoons, underwater sandbanks, etc. Now, when we overlap these with this yellow areas, then we can see what part of this EU habitats is degraded or lost. And that in this very drastic calculation, meaning severely degraded habitats, is 162 kilometers square. which is 3% of these habitats only. And now subtraction gives that we have 5,315 square kilometers of habitats that are not totally degraded. Okay, this was only the very severely degraded, and now we ask ourselves the extent of disturbed habitats. So we can look at the EU habitats or specific IUCN habitat types, which are often characterized by key or keystone species. So we have a lot of data on the environment here. Secchi depth from the 70s. Secchi depth means water transparency, and you can see that it is has been going down a little bit from the 70s, and then we have a green line over there, which is actually the target condition according to Marine Strategy Framework Directive and Helsinki Commission. And you can see that the average Secchi depth is at about 4.2 meters, and we wish that the water would be much more clear. The target is at 5.5 meters, and the difference is 1.3 meters. So it means that the condition is suboptimal. So how can these data, Secchi 4.2 and 5.5, be used in estimating ecosystem extent and condition? Well, it's based on the fact that many key species or habitat-forming species that are supporting many ecosystem services are very sensitive to lack of light. So the approach is to first model the present-day species distribution at this present Secchi 4.2, and then secondly model or make another map where we model the species distribution at this target Secchi depth 5.5. And then we can assume that the difference or the lost distribution means a corresponding decline in ecosystem condition, and also a decline in the capacity of the ecosystem to produce benefits. So an example is bladderwrack, which is a keystone species in the area. It provides food and shelter for fish and stores carbon, and it's also giving well-being for humans when they see that it's healthy and water is clear and everything looks very nice and beautiful. And now this upper graph shows the present distribution modeled in a specific southern Finland area. And this second picture shows the scenario of reaching this good environmental status, meaning Secchi 5.5. And the difference between these ones would be depicting the decline in condition, or the difference between the wished environmental status and the present one. And these information types could be used for seeing what is the extent of areas in good condition. So to conclude, potential of the marine ecosystem to produce ecosystem benefits can be determined from the amount of degraded habitats and the disturbed habitats or species forming these habitats. And this approach allows also to define clear targets to be set for ecosystem condition to provide ecosystem benefits. Thank you for your attention.
Great. First, I want to express my gratitude for MAIA project invite us to present our earlier work. And here I will present a topic about bioeconomic modeling of coastal cod and kelp forest interactions, co-benefits of habitat services and fisheries, and carbon sinks. Right. So, yeah, kelp harvesting has been in Norway for decades, and it has only been machinized and industrialized in 1970, including bottom trawling. 40%. The depth of harvesting is between 5 to 15 meters, and deeper than 20 meters is forbidden to harvest. So the main species, economic species for harvesting is Lamina hyperborea. What we call it usually is called big kelp, and they're as large as they look like a tree actually underwater. And Norwegian agency fishery estimates that about 0.3% of total Lamina hyperborea biomass in Norway is harvested for industrial use. They are very profitable in terms of the industrial. They are the raw material for algina, for example. Current harvesting regime, you can see from the map here, is that from the southwest of Norway, from County Rogaland, the whole way to Trøndelag, County Trøndelag. And if we zoom one part out, you can see a different harvesting regions, and the harvesting regulation divides each coastal harvesting areas into 5 fields, and only 1 field is open for harvesting each year. Or in other words, each harvesting field is only allowed to harvest every 5 years to secure the recovery of the kelp biomass. And due to the bottom condition along the Norwegian coast, with the hilly area and difficult harvesting conditions, so even in these harvesting, the areas that is allowed to harvest for industrial harvesting, and there are still large areas of pristine kelp forest. However, the bottom trawling has created conflicts with other usage and interests along the coast zones, for example, fishery industry. As we know that kelp forest is important habitat species, provides, for example, the hiding nursery and hiding places for juvenile fish, and provide the main food sources for various fish species. So that means kelp harvesting, on one hand, it provides a huge benefit, but on the other hand, it could have environmental impacts. So as I mentioned earlier, that it has huge conflicts with local, not huge, but documented conflicts with local fishery industries. And as a removal of large kelp reduces kelp forest function as habitat for a certain period until the kelp community is reestablished. So most Norwegian studies conclude that kelp biomass can recover 3 to 5 years after trawling, but it takes longer, such as 6 to 7 years before all flora and fauna will be established. So that means the ecosystem service impacts last longer than the impacts on last longer than the biomass itself. On the other hand, we know that kelp forest is important blue carbon, and it store the carbon in their biomass, and it's still a hot topic with how much carbon will be sequestrated by the kelp forest in the deep sea, and due to the debris. And from a study from Goodison 2011, showed that each ton of kelp wet weight biomass can store at about 100 kilogram carbon in their body. So current kelp harvest regime has do not consider the ecosystem service impact, let alone the values of fishery and values of blue carbon stored in the kelp biomass. So what we try to do in our early paper about under the same name is to ask, how should kelp harvest change if fishery and carbon storage values are considered? So here I thank my collaborators, Kofi Vondulia and Claire Armstrong, especially for making this study accomplished in a way that we envisaged in the beginning. So we in this study we use a bioeconomic model with a social planner to maximize the profit not only from kelp harvesting but also the profit from cod fishery as well as the values from stored blue carbon. We take into consideration that the interaction between the kelp habitat and the cod fishery, in particular, for example, the kelp habitat effect goes through two channels. One channel is that the kelp habitat increases intrinsic growth rate of coastal cod, as we know that they provide important hiding place for juvenile cod, so that their the predator pressure reduces. And the another channel, the habitat's effect goes through the improved carrying capacity of coastal cod. And if we're thinking about larger kelp biomass, provide this larger area for coastal cod to survive. The simple bioeconomic model actually showed that when we consider the habitat effect, the harvesting of kelp should be reduced. And if we add the carbon storage effect and considering the values of blue carbon, in addition, the kelp harvest should be further reduced. So the next step is we aim to have a better linkage between kelp forest habitat and the cod biomass, because in this paper there are limited ecological data available. So we rely on certain guess estimates, and another next step will be downscaling the harvesting and the carbon values into smaller regions, and also take into consideration the different management regimes of coastal cod, because there are different management regimes, northern the 62 northern line and from the southern part. And we also want to include adaptive harvesting and multiple agents, and adapting harvesting actually in a way to consider it is to me is a more realistic way to consider the ecosystem dynamics into decision making when we plan only a short period at a time, and then renew our planning in the next period. And also we aim to integrate cultural services with provisioning and together with provisioning and regulating services we mentioned here. And the conclusion is that bioeconomic models and other models integrating ecosystem services and values are useful tools to show how ecosystem service values, and if we say accounts, can be included in private and public decision making. In our kelp case, for example, the kelp harvesting has been dominated by international harvest company, and fish quotas are released by public authorities. And the modeling outcome also provides a knowledge base for what policy and economic incentive measures instruments can be used to facilitate take-up of ecosystem services and their values, and how to quantify the incentive measures. Because in the modeling approach, we kind of could use provides quite specific values and their ranges if we're thinking about uncertainty. Okay, thank you very much. If you have more questions, please contact me by this email. Thank you. Thank you.
Okay, thank you very much for all your presentations, and I think we can now move on to the questions and comments. So I think there was the first question or comment was to Tinu about that I understood that it's are the challenges caused by mobility of fish species and dynamic ecosystems different for ecosystem accounting than for cost-benefit analysis? And does the broader scope of ecosystem accounting compared to cost-benefit analysis, usually focusing on one topic, increase the understanding of these issues? And this was sort of my interpretation of the comment by Verendra, but I don't know if I got this correctly, and how would you reply to this, Tinu?
Yes. Well, I think the challenge for CBA and for ecosystem accounting is the challenge of perspective is different, as you have mentioned that well about define the scope probably is because the CBA the challenges might be decided the scope compared to national account the scope border scope is clear. But I think for the ecosystem accounting, the challenge is how to disaggregate the result estimate from the ecosystem perspective to the national, how to disaggregate data to the national border. Well, we can go back to the fishery case that we have mentioned that. They predict the expected services for the asset account, and of course it can go into the simple way that accounting for the one for the resource account that you just predict the same harvest for the future. But if you want to go back to the ecosystem accounting that we predict the expected from the bioeconomic model. So the prediction was based on the whole, based on the ecosystem scope. So the challenge is that how to integrate the result estimate from the ecosystem scope to the national border. And well, currently until now we quite often also still use the catch share, but I think it's discussable if other kind of disaggregating way will be more suitable for the ecosystem accounting perspective.
Thank you. And then there was another comment by Verendra. So your Tinu's presentation focused on the problems and challenges. Yes, the available information is not perfect, but what can we do with the information that is available? For policymakers, it's not always necessarily to have 100% perfect information. For strategic discussions on strategic directions, data on orders of magnitude may often already be useful to support policy discussion and decision making. So let's look at the glass being half full. Let's see what we can do with the information we have, and if policymakers need more detailed data on particular aspect, then we can focus our monitoring research, etc. on that. And I would just like to comment that I agree with this, but that we should make most out of the information that we have, but should we be eternally satisfied with the glass being half full? So I think it's also good to point out what would be required to do a more reliable analysis and to compile more reliable ecosystem service accounts. But I don't know, Tinu, do you want to add on this? I can't hear you now. I don't know if you're muted or.
Well, I agree your reply. It's it's probably not specific to the question, so.
And then there was a question for Elina and Markku about the. I think there has been some further discussion in the chat about in modeling. David Barton asked that in modeling ecosystem condition reference level, was it an option to identify pristine condition rather than good condition or non-anthropogenically forced natural condition as compared to good condition? So what do you say, Markku?
Yeah, that is a thought, of course, but usually that is very difficult to define what is a pristine condition. The Baltic Sea has its natural problems, so to say. For instance, the anoxia or hypoxia of the deep bottoms is a common phenomenon which is partly natural, but enhanced and worsened by human disturbance or impact or nutrient loading from land. So yeah, that's kind of a philosophical question. Is there a pristine condition for the Baltic Sea, and what should it be? The present state of the Baltic Sea is only 10,000 years long, and before that it was a little bit different. And the human impact, as actually Adrian Comte points out, that people have affected the earth from the Stone Age basically, but at least for 12,000 years. So that for that reason we always try to use these commonly accepted or published reference levels for any parameter that we link to the environment, like the Secchi depth as I showed. Thank you.
And then there was a question from Kristina Weidemann for target setting for Markku. For target setting, do you link with the Habitat Directive, Water Framework Directive, or any other targets?
Yeah, for the Secchi depth or water transparency, for instance, that is the same target for Water Framework Directive and for the coastal areas and Marine Stewardship Framework Directive. In the habitat approach, where we actually modeled the distribution of bladder wrack, we don't have a target for the spatial extent of bladder wrack per se. So we just used the Secchi to define environmental status that is kind of wished for, and then defined the spatial extent of this key species bladder wrack based on that. And bladder wrack per se, or the species itself, is actually not mentioned in the Habitats Directive, but it's in listed as a threatened habitat in the national assessment of threatened habitat types. And that's why we use it as a specific target species for analysis. Thank you.
Thank you. Do we still have time for one question for venting? I think we have. So this is from David Barton. So he agrees that bioeconomic model is useful for management optimization. And the question is, monetary ecosystem accounts would have harvesting at historical levels rather than efficient harvest level determined by bioeconomic model. Further, ecosystem accounts would not integrate externalities on cod fishery and carbon evaluation of kelp harvesting. Do you see several versions of monetary accounts being prepared? So historical, efficient, or some other types?
Right, just give me a second. I'm reading the question again. So yeah, right. Yeah, at the moment, the as this paper, because it's produced long before we actually go into ecosystem accounting, so that paper was using a traditional bioeconomic modeling, and or we haven't made it spatial yet, but it has been ambition that to make it spatial at the same, so it's more close to the ecosystem accounts, and at the same time that we also trying to make it more kind of harvesting in at each year level to project for example, the future harvesting based on the historical harvesting, and to tune the model better. Yeah, so the ecosystem accounts will not integrate externality on cod fishery and the carbon evaluation of kelp harvesting. Right. Well, right. I would say that an ecosystem accounts is kind of kind of static point at each time at a spatial area. We show that how much kelp biomass, how much, and for example, the regulating the asset value of carbon stored inside kelp body, and also, for example, the cod fishery values at a kind of static point value at each spatial area, and the bioeconomic modeling actually is kind of make use of this data and trying to project what we could do in the future if we're trying to take into account the externality of kelp harvesting on the cod fishery and the carbon valuation, so that we it's kind, to me it's kind of how to use this ecosystem accounting data in the policy and the decision making, so that to kind of to realize the ultimate goal of accounting, right? To include environmental impact and externality in the economic development. Yeah, thank you.
So then would it be possible to assess the value of kelp asset under different policy scenarios, taking into account different future ecosystem service flows like carbon and kelp? And
right, that's a really good question. That's actually is kind of a key point we should focus on when we're doing the future, when we do the future analysis, because that's about under different. The dynamics is not only about baseline dynamics, is also so the carbon storage itself kelp itself can be affected in the future. For example, the climate change and other effects, and also the cod fishery. So yeah, the trend effects has to be considered.
Are there any other questions? I actually think we are a bit ahead of time. I was thinking that this discussion ends at 10 o'clock, but it ends at 10:15. But should we have the health break now, or are there other questions that you would like to ask?
I think
we started a bit early.
Sorry, I think there is from Vera is also another question to this. Interesting and for policymakers relevant thought. If more kelp harvesting reduces fish catch, what is the most?
Sorry, I missed that one.
Sorry, I can just read it out directly. What's the most profitable level of kelp harvesting in the long run, taking into account this type of feedback loops? Yes, thank you, Vera. This is exactly what we're trying to achieve. Yeah, and currently we're thinking about it's mainly the direction of kelp. Kelp habitat is beneficial to cod, and we of course, if we go more complex ecological feedbacks, it may be possible to also to consider, the cod species. Actually, cod fish could actually affect the other species, and therefore also affecting the kelp habitat itself. Yes, I think we will go step by step to include the externalities and also possibly in the future and the feedbacks on that.
Thank you. I think there has been a hand up by Palavan Mail. Do you have a question to some of the presenters? Or is it an old hand or?
Sorry, this is the old hand.
Okay. And then Marco has a question or?
Comment. I think it was a very good point thinking about the balancing of different bits gained by, for instance, kelp harvesting and cod fishery. That of course applies to almost any type of usage of the marine areas and seas, and we in Finland have made a quite advanced optimization analysis of wind power in the Finnish sea area, and that has been taking into account economical factors, societal factors, and of course environmental factors. And that is based on known facts of, the areas that are ecologically important and the costs of building wind power in the open sea areas, and then factors like visibility to housing and summer cottages of the 200-meter high windmills. But the next step, and very important step in such an exercise, would be exactly to figure out what are the pros and cons of increasing the wind power potential in any sea area, taking into account the possible declines in habitat condition and so forth. And you would of course expect and hope that the benefits gained, the green energy or carbon burning of fossil fuels would decline, and everything goes for the better. But on the other hand, there are other benefits that may be lost due to the building of such big wind parks, so to say. I'm not saying that I'm opposing building of windmill parks at all, but I'm just saying that we lack such a accounting of the pros and cons that take into account all these possible benefits that arise from other parts of this equation, including human well-being and also economic benefits of rising from habitats. Thank you.
Are there sort of massive plans to increase windmills in Finland?
Yes, of course, as almost everywhere.
Yeah.
We are lacking in terms of production of clean energy. So there are quite a lot of wind power built on land, and that starts to be almost finished, there are no places left that would not be severely or fiercely opposed by people who are living on land, and therefore the gaze is turned towards offshore wind power. And once we have cleared out the practical problems of building wind power in the open sea, then there will be quite a lot of increase in that. And for instance, we just 2 days ago were giving an opinion to Swedish enterprises that are actually planning a windmill park of about 300 windmills, approximately 250 meter or almost 300 meters high in the southern Botnian Sea on the Swedish side or EEZ area. Thank you.
Thank you. I think there was one sort of comment or question that I missed, that was from Adrian Comte. A new paper by Ellis et al. In Nature shows that people have shaped most of terrestrial nature for at least 12,000 years. How would pristine condition look like in that context? And I think this was for Marco.
Yes, I already referred to Adrian's comment, which was kind of a reply to David.
Okay.
It's quite difficult to define the pristine condition, especially in the Baltic Sea, which has a geological history of 10,000 years, and then well, the history of human influence is almost the same. Thank you.
Are there any more questions or comments? I guess not. So should we now start our health break then and continue then after 15 minutes at 10:30.
Thank you very much.
Okay, welcome back everybody. My name is Toila Oinonen. I work at the Finnish Environment Institute, and I'm also part of the MAIA project, and I'm sharing this second part of our webinar. And we have 4 presentations, and as in the first session, you can type your questions in the chat box, and Lisa will take care of the discussion section. So welcome, Michael Board, and the floor is yours.
Good morning, and I presume you can see the screen there. Very, very early morning for me, but I really don't mind. The presentations have been fascinating so far. I really get the feeling that we're part of the same team. We're trying to solve the same kinds of problems, working with the same kinds of ideas, and hopefully there are ways of continuing the discussion. When Marco asked me to present, I thought that an appropriate topic would be to discuss how our vision of ocean accounting is different from simply ecosystem accounting, which isn't all that simple in the first place. But from the presentations so far, it seems that you've already been taking just as broad a perspective of your accounting work as I'll describe in the ocean accounting framework. So just to give a little bit of the history, that, believe it or not, the ocean accounts and ecosystem accounts can be tied back to deficiencies in the system of national accounts and trying to measure economic production. And in the early 1990s, statisticians came to the realizations that the system of national accounts is not accounting for natural inputs, that if they didn't account for natural inputs, then they don't really understand the economy. And even now, if you look at the manual System of National Accounts, all 750 pages, there are about 5 pages on ecosystem accounting, and it points to the SIA. So that was the start of the SIA, actually account for natural inputs to the economy, natural assets, a lot of the terms that we're still using. And by 2010, there's a realization that even the SIA central framework wasn't accounting for the non-owned assets and ecosystem services. And this begat SIA ecosystem accounting. That's when I first met Lars 10 or 11 years ago. We're struggling on how to deal with that. And that's where the framework of extent and condition and services, supply and use started. And that's been refined. But even beyond that, in 2017, I was working at UN ESCAP in Bangkok. That's the Regional Commission for Asia and the Pacific, and countries, largely through the statistical offices. I was working with the statistics division there. We're asking, how do they address SDG 14? And SDG 14 is partly about ocean conditions and ocean quality and ocean ecosystems, but as much about the ocean economy and sustainable use of the ocean. So we had to think about how we would broaden the statistical frameworks that we have now, the System of National Accounts, the SIA Central Framework, the SIA Ecosystems, to cover this broader area of SDG 14, life below water. So my slide isn't, oh, here we are. So what we ended up with isn't going to be very surprising to anyone, but it's really combining the frameworks that we have. We took a broader vision of ocean assets than simply the ecosystem assets, and dealing with non-ecosystem assets, the minerals and energy that's in the ocean, and that's already come up in some of your presentations. And between SIA ecosystems and the SIA central framework, we have a reasonable way of conceptualizing those ocean assets. We talk about a broader sense of ocean services, which is the biotic and the abiotic. So it's the services that we're getting from the minerals and energy, the abiotic assets, in one conceptual framework, not necessarily one classification yet, or one table. We have there are obviously conceptual difficulties in combining some of these ecosystems and non-ecosystem assets. We think of ecosystem assets as the place, and the SIA Central Framework has environmental assets like fish and plants that are external, but not necessarily external, but they're already embedded in the ecosystem, but we're accounting for them separately. The same with the biotic and abiotic services. We needed a way of looking at the pressures on the ocean ecosystems, and the SIA Central Framework already provides guidance on how to do accounts for water emissions and solid wastes. What we do suggest is that if you do those accounts by catchment area, drainage basin, then you have some way of linking those to impacts on the coast and marine waters. We'd only been partially accounting for the economic aspects, that we look at the values of some services to the economy and the value of some natural inputs to the economy through the SIA ecosystems and SIA Central Framework. But people had been doing ocean economy satellite accounting, which is taking a look at the economy from the ocean sectors that are dependent on the ocean, and those activities that occur on the ocean and those that occur for the ocean, like shipbuilding, and what is that economy worth. So there's a lot of interest in understanding that aspect of the ocean economy, and that links closely back to the system of national accounts. And again, to complete our coverage of SDG 14, we need to look at governance issues, including ownership and legislation and management and technology and expenditures. Only parts of those are covered in the SIA, mostly the central framework. So that, in a very simple overview, is how the different bits of the SIA and system of national accounts fit together, and the little bits that we've had to add. And we have a technical guidance document. I'll provide some references later. So, yeah, various projects are interested in various bits and pieces of this, that no one has done a comprehensive ocean account, and many countries are working on specific parts of it, but to have this overall framework helps to see how things link together. So when I say we, and I've provided a list of references, I'm part of a global ocean accounts partnership, which is partnership of about 18 members, including countries and research institutes. I'm a member on two different levels. The University of Ottawa is a member, Fisheries and Oceans Canada is a member, Statistics Canada is a member, SCAP is a member. It's hosted by the University of New South Wales in Australia. It's a contributor to the High-Level Panel for a Sustainable Ocean Economy. We're an action coalition, which means that we provide advice to the countries on how to implement their targets, and there's an initiative to conduct ocean accounts in all 14 member countries of the high-level panel. Norway's a member, Canada's a member. I don't think anyway. So not every country is a member of the panel. We've had 3 global dialogues so far on ocean accounting, and some of you have participated. We bring together statisticians, scientists, and policy experts on discussing priorities and arranging for pilots and doing presentations like you're doing now on results, on research. There's a terms of reference if you're interested in becoming a member of the Global Ocean Accounts Partnership, and there's a technical guidance and information on our global dialogues, which were recorded. I'm a member of Fisheries and Oceans Canada, Statistics Canada Ocean Accounts pilot. We're working on a pilot on several levels, not quite as rich research results as I've seen this morning, but we're certainly making progress in improving the ocean economy statistics. The big challenge there, I don't think anybody's mentioned the challenge of having lots of data, but it's just in different places. So Canada's rich in data and studies, and it's all in small areas. And I guess as Tin Yu mentioned, that it's quite difficult to integrate. There's a special project on seagrasses and eelgrasses looking at bringing together the data for that, and it's the same as Mark, who had mentioned that you get spots of data on the actual extent of the species or ecosystem types, and then you have to kind of assume the rest from the conditions. But it's good to put the effort into bringing that data together in one place. We're also compiling a bibliography of data and research and coding that to the framework. I've already shared that with Adrian, and he shared me with some of his bibliography, but it's always useful to have research papers and to take a look at them, and we have students to code them to the framework, and should be able to make that public on the Ocean Accounts Partnership website fairly soon. There's quite a bit of activity in the international community besides the Canadian pilot study. Australia has done a fairly extensive one and are investing in much more ocean accounting. China, Malaysia, Samoa, Thailand, Vietnam have done small studies, and most of those studies have resulted in ongoing research work. What I would like to encourage more of is for this research work to actually be published. I'm finding the occasional fascinating publications, articles, and the more we can publish and share, then the broader the community gets. United Nations Statistics Division, who are in charge of the SNA and the SIA, have proposed a SIA Ocean. That the idea there would be to take the technical guidance that we already have and review that and revise that with the help of experts over the next couple of years, and to have an official UN document rather than our unofficial technical guidance. And there's ongoing work related to the Decade of Science and the Secretariat for the Convention of Biological Diversity on their global biodiversity framework. So Ocean Accounts is quite quite a topic of discussion these days. We have a hashtag Ocean Accounts if you want to use that in Twitter and other places. So just a quick conclusion that we're trying to bring coherence to a fragmented field by bringing convergence among concepts and classifications, by applying international standards. And we see this as opening opportunities for linking individual research areas. So by having a broad interest and a broad need, like the presentation this morning, it's providing a context for these individual pieces of research. And our hope is that maybe accountants can save the ocean. That's a long story. Anyway, so I'll leave you with some references here. The things that I've been talking about, some recent papers. We published in Marine Pollution Bulletin. Some you'll already know about, some you might not know about. Some background information on the webinars, the other pilots that are going on, the SCAP website, an overview of the fisheries and oceans pilot. So I'll leave you with that, and I'm happy to take questions when we're in the questions session. Thank you.
Thank you. So you see my face again, and if you feel bored about it, so it's okay that you take a walk or whatever. So yeah, this is I will have a presentation about the values of deep sea ecosystem restoration, a case from Don Canyon in the Bay of Naples, Italy. So it's a collaboration between me and Imanko Ono and Stephen Heines from SAMRU, the Marine and Socioeconomic Units at the National University of Ireland, Galway. And it's the research was done and funded by the Marine Ecosystem Restoration in General European Seas and Mersey's project. Right. The Don Canyon is a main canyon crossing the Gulf of Naples. It's up to 1,000 meters deep in some places, and follows two main branches, the eastern one and the western one, and merging in a single branch. The Don Canyon is located close to the Gulf of Naples, that is among the most densely populated Italian region. And along the Gulf Coast, there are about 30 ports and more than 300 maritime constructions. Over many decades, this canyon has been subject to high intensity human uses, like linked to coastal zone pressures. And this has resulted in change of the pristine environmental conditions of the canyon. The anthropogenic activities influence the biodiversity of benthic fauna associated with the canyon system. Having different impacts when different benthic groups from micro to megafauna are considered. In order to restore the canyon system, there has been experiment conducted under the Horizon 2020 MERSES project to deploy a number of artificial reefs in the main axis of canyon at approximate depth of 200 meters. And these artificial reefs, called arms, provide a basis for new organisms to grow, and especially the corals, deep water corals. And by this means, they will help the adjacent ecosystem to recover as well. In order to scale up the restoration activities, there is a planned future scenario, and that is to create a 2-hectare marine protected area and combine this with active restoration activity to restore the deep water coral reefs and the adjacent ecosystem and the services. So here you can see kind of planned area of the size of 2 hectares, with all the dots indicating the potential and the artificial reefs, the arms, which will be laid to the bottom sea at about 400 to 500 meters deep. Right. So we know that the restoration can be scaled up, and our question is how much is the non-market value for the deep sea ecosystem restoration of the canyon. We carried out a survey among the whole representative respondents, which can represent the whole Italian population, and to ask them about the attitudes towards marine ecosystem restoration. And we use also contingent evaluation approach, which relies on using stated preference of surveyed individuals in Italy to model national willingness to pay distribution for restoration of Don Canyon. Yeah, well, at the same time, we'll also calculate the regional willingness to pay distribution for restoration for the canyon. And the stated preference elicited using the single bit discrete choice format recommended by NOAA panel. So this message is probably familiar to most of environmental economists here. So the contingent evaluation scenarios look like this. A restoration and monitoring plan implemented in the Don Canyon that achieves the following. The management and plan attributes include biodiversity and, for example, the abundance of animals such as fish, starfish, corals, worms, lobsters, sponges, and also we also consider the density of marine litter on canyon floor, because the litter also marine litter has also been regarded as a problem and pollution for the canyon. And we also consider the size of protected area in canyon. So the biodiversity and level achieved after restoration, we assume we make the target quite high, that is back to pristine habitat levels for the canyon, and the density for marine litter we also target at a kind of good status. That means only 0 to 1 items of litter per square kilometers, and also the size of protected area is the size of the planned scenario of marine protected area. And here this is a summary statistics of our surveys. There were totally 1,060 individuals across Italy answered our questionnaire. And the estimated mean willingness to pay per person per year are estimated by the sample selection model. Yeah, here you can see the mean willingness to pay per person is about 35 euros per year, actually. Results from a representative, the results also indicate the importance of accounting for protected zero bidders in contingent evaluation studies, because we experience a quite high percentage of zero bidders, and we identify them actually as protesters. And we argue we argue that this is probably because the environmental good is in a deep sea ecosystem, which is relatively unfamiliar to respondents. And this is what I presented is all included in the paper here. If you have more questions, could resort to that paper for details. And we also, from the project, we know that the restoration success has been highly uncertain, and how uncertainties, and including the uncertain successful rate of restoration, will affect the benefits of restoration, or the expected benefits of restoration. So, following up that study, we created a Markov model, or we developed this model shown here to illustrate the transition probability between different status of ecosystem. F state for fail and the deteriorate ecosystem, and S state the successful or improved ecosystem. The PFF states probability of staying in the deteriorate ecosystem. That means our restoration does not succeed, and PFS means the probability from deteriorate ecosystem condition to improved ecosystem condition, which means the restoration actually succeed. And because due to large uncertainty and environmental factors and other variable factors, it's also likely that the restored ecosystem will flip back to the deteriorated ecosystem. There you can see that there are certain probability that ecosystem will going back before the state and to the status before the restoration, and even succeed in a short period. And also, of course, we in the long run we will hope that we will always stay in the improved ecosystem after restoration project. We also we resort to expert opinion to estimate the transition probabilities listing here. And we incorporated the value studies in the social cost-benefit analysis of Dong Canyon, and trying to, with a 10-year restoration project with 50 learners, and that's 50 learners, and total restoration cost is estimated as $500,000. And we also consider the high uncertainties associated with restoration success rate, and incorporate this Markov modeling based on expert opinion. Then we show then we calculated the net present values and distributions. So we can see that the orange line shows the net present value distribution under uncertain probabilities, and we consider all the uncertainties in different sources, including the valuation as well as the costs. But here is a certain probability and uncertain probability difference only for the successful restoration success rate. So here we can see that uncertain success rate affects the probability density distribution of net present value significantly. So the valuation study hasn't been developed to illustrate the spatial difference of values. I think it's important next step we should do. And we do find out from our analysis that ecosystem accounting could probably be important to study the effects of restoration on the ecosystem and the ecosystem services and values both ex ante and ex post. So our valuation case shows the values can be connected with ecosystem condition change, which is a kind of ex ante study before the project actually is being scaled up, and most of our economists are familiar with this type of study, and we really has ambition that to use also SEA to kind of monitor the impact of or the effect of ecosystem restoration on ecosystem and ecosystem services and value change after the restoration activity has been scaled up. So as we know, restoration has been mentioned as a potential area for SEA, and I do think there's an area that we will further pursue in the future. And also from our valuation and CBA analysis, we can see that restoration costs are very different from the non-market ecosystem service benefits. And from our MERCIS project, we also see that marine restoration projects are largely underfunded, which means the restoration expenses will not correctly reflect the value of ecosystem services and natural capital. As many ecosystem services cannot be traded in the market, so it is important to consider the non-market benefits of ecosystem restoration together with the costs. Yeah, and in the last, I thank the funding source from Mercy's project and support of also the Italian colleagues for these studies. Thank you.
Yes, so I'm going to be presenting both presentations in a row. That's fine, and I'm going to try to perhaps speed up. It's going to be an overview of kind of everything that we're doing in MAIA, so there might be a lot of information. So don't hesitate to ask questions at the end. First on the biophysical accounts developed in France, and a little bit of history about what has been conducted in France on environmental accounting outside of the MAIA projects. There hasn't been any official ecosystem account to date, but there's been a lot of work, notably by the public sector, and there was a report by Stiglitz and Fitoussi in 2009 on the new indicators of wealth that looked at going beyond GDP as just a measure of public policy evaluation, and they found that it was perhaps not appropriate to adjust macro aggregates, but advised for a dashboard of selected indicators, including different dimensions of sustainability. We also have the Economy of the Environment accounts published by the Ministry for an Ecological Transition. We have forestry accounts, and we also have natural patrimony accounts. That was one of the precursor on natural capital accounting in the 1980s. We also have the work of André Vanoli, a national statistician who developed the concept of unpaid ecological costs, and some experimentations on these concepts on carbon, air, and water. So on marine ecosystem accounts, we're not going to start from scratch in France, because we can build on already existing research and public policy works. And first and foremost from the Marine Strategy Framework Directive, which is a European directive. It's integrating policy on the management of marine ecosystems. And there's been already published articles about the good ecological status of the different descriptors, and then also on the cost of degradation using the maintenance cost approach. Then we have work conducted by the French Biodiversity Office, notably the Carpe Diem project, which mapped habitats, marine habitats, and also risk of the physical pressures on the integrity of those habitats. We have the French Assessment of Ecosystems and Ecosystem Services that provides a solid conceptual framework for the development of the ecosystem accounts. And we also have other works that are not used here but are interesting on the system service recreation by Martin et al. In 2018, and on an input-output model on the restoration of estuary by Cordier et al. In 2011. So what we first did in the MAIA project in France was to conceptualize the chain of accounts that we wanted to experiment. So in green, you see the ecosystem accounts that are proposed in the CIEA, the extent and condition of ecosystems, the ecosystem service supply and use in biophysical terms, and then the ecosystem service supply and use in monetary terms, which are then used with scenarios in order to get ecosystem assets. So in France, we built the extent and condition accounts, and we look at important reference levels, which are based on environmental targets, in order to then develop economic accounts using the required costs, maintenance and restoration costs to attain those reference levels, good ecological status. And then the difference between these and what is actually paid already would be unpaid ecological costs. So for the spatial model of ecosystem assets, we use the MAIA spatially explicit model with a resolution of 1 arcminute on the French exclusive economic zone, and this zone is cut into 4 pieces, which are the marine subregions that are the unit of reporting of the Marine Strategy Framework Directive. But they also cut between coastal, intermediary, and offshore zones, which are other units of reporting for the Marine Strategy Framework Directive, but also for the Water Framework Directive. That's an overview of the accounts that we produced on the extent and condition accounts. So the condition accounts are divided into the benthic, the seafloor, and the pelagic, the water column areas, and we're going to start by the extent account. So the project Carpe Diem has produced a map of benthing habitats, which is a composite map using different data sources, which span from 2010 to 2018. So we have a single point in time of these maps of benthing habitats. There's no trend in time that we can follow, but maybe that's not too bad because the marine habitats do not change as frequently as terrestrial habitats. So that's a map of the extent accounts. We used the UNIS classification level of habitats. That is a European classification. There's several levels. The further you go up the levels, the deeper you get into the complexity of the habitats, and the finer you describe them. At the level 2, you have 7 marine habitats and 3 coastal habitats. But then, so we can then look at the different distribution in surface and in percentage within the different marine subregions and for the whole economic exclusive zone. And we can zoom in into finer classification levels up to level 3. That's becoming a lot more habitat classes. And then you can go, we have the data to go all the way to level 4 or 5. But using our spatial resolution, we use some of the complexity. At the level 5, there's 120 different habitats that are present in France, but at our spatial resolution, we can only describe 80 because the cells are too big to take into account all of the different habitats. Now on to the condition accounts. So there's a large number of possible indicators that one can use to describe the condition of marine ecosystems. And so, because we're not ecologists or biologists, we looked at what existed already, and so we used the French assessment of ecosystems framework, which attempts to select parsimonious number of categories and indicators within those categories to reflect important values for society. So those 3 categories are the heritage dimension, which is the conservation status of habitats and species, the capacity of ecosystems to provide in a sustainable way goods and services, and then the underlying functioning of those ecosystems. What is kind of neat is that the Marine Strategy Framework Directive works in descriptors that try to define the important dimensions of marine ecosystem conditions to manage. So there are 11 descriptors in the Marine Strategy Framework Directive, and they can be classified into this different category of conditions of heritage, capacity, and functionality. And so this is a list of the potential indicators on those dimensions of marine ecosystem condition that we identified. In black are the ones that we could have access to spatially explicit data sets in order to construct the accounts. And in orange and red are either data sets that are not spatially explicit or that we cannot find or that are incomplete. So for the heritage dimension, we have indicators on the abundance of species and the abundance of habitats, the red list index, the state of protected areas. So those are linked to the D1 and also sometimes D6 descriptors of the Marine Strategy Framework Directive. For the capacity dimension, we have the fish stocks, that's the D3 descriptor, and then we could have water quality for important commercial species, shellfish, for instance, but we didn't find spatially explicit information for this indicator. Then on the functionality dimension, we couldn't find any data on non-indigenous species and trophic levels, but we have physical integrity and eutrophication. So again, for these conditions indicators, there's often problems with the temporal availability of data sets. So in greens, those are the indicators for which we have temporal data sets, and in orange are the ones for which we don't have, either because they have only 1 year time series or because they are composite maps or averages across a number of years. So some examples of maps of condition indicators. Here you have the integrity of the seafloor, which is approximated using the risk of concomitant effects of physical pressures. So that's linking different activities that have an impact on the seafloor, like dredging or extraction of sand. And then that's integrated into a matrix with the sensitivity of different habitats to those different human activities to produce a map of those risks. We can also couple this with the different extent of marine habitats. And so here we took the two examples of two habitats, mer beds on the left and the seagrass beds on the right, which are important for community interest at the European level. And so we looked at the distribution of these species on the gradients of risk of physical integrity. And we can see that mer beds are not affected by physical pressures, but seagrass beds are very affected by those cumulative effects. And so that could be interesting for management. We also have, so for example, densities of marine mammals. Here is the turquoises, which is a protected species, and so that can be interesting to map it with conflicts or fishing, for instance. And then, so we have the reference or target condition account. So what we mean by reference conditions are targets set in policy directives that are important for every dimension of the condition. This is not a reference condition as some pristine or historical condition. This is really a policy objective that is negotiated politically based on technical and scientific information and on policy agendas. So for the heritage dimension, we have non-declining abundances and surfaces, so that we're not sure how to use it, produce anything meaningful yet. We have the level of captures. We have policies on loss of biodiversity and on protection of species and habitats. Those come from the Marine Strategy Framework Directive, the Habitat Directive, both Power Barcelona and Attra 2000. On capacity, we have the maximum sustainable yield, which is a fairly standard way to measure the sustainable use of fish stocks. And then on functionality, we have pollutants levels, we have thresholds of chemical and biological variables linked to eutrophication. And then we also have trends, which we don't know how to use. So those are some examples here for the good ecological status of fish stocks. We can see that of the stocks that are actually assessed, there's an increasing number of fish stocks that are within the good ecological status, but there's still a wide range of stocks that are that have not reached this good ecological status. Here for eutrophication, we looked at different subregions and then the total coastal zones of France, and we see that there's a significant area, notably in the Celtic Seas in Brittany, in fact, that has not that is above the thresholds for eutrophication. So, what could be the policy use of those ecosystem accounts? Well, first, try to build the standardized indicators to monitor the achievement of specific policy objectives, including spatially explicit strategies and objectives, and so that could inform marine spatial planning, which tries to delineate zones of different use, sustainable use, or access to different kinds of human activities. It can be used to monitor environmental degradation, assist in the identification of data gaps. So we've seen that some of the indicators that we've identified that could be important to assess the condition of ecosystems don't have data sets. It could be used to harmonize and integrate existing ecosystem monitoring processes. So it could be, for instance, coupled with compensation measures. There's a especially explicit data sets in France now on restoration projects, but they don't overlay it with the map of extent or condition of the ecosystem. So that could be an interesting way to have a look at that. And then could analyze trends over time between countries, foster the development of more integrated policies, which marine policies are already pretty integrated. And then the next step would be to relate it to economic agents and their impact on degradation of ecosystems. Okay, so that's for the first one, and then we can move to the second. I'm sorry, I'm already late on what I said I would do. But on the economic accounts of maintenance costs, so we take the same conceptual framework, and now we're going to look at what is in red, so the reference levels that are going to feed into assessing required costs, and then unpaid ecological costs. So, as I said, environmental objectives could be either, I didn't mention that, but they could be based on either science-based targets at a really high level, that could be like planetary boundaries, or they could be more collective values, negotiated policy documents, either international norms like the Paris Accord on Climate Change or the Aichi targets, or more national or even local public policies. So we have the good ecological status of water. We have also no net loss of biodiversity in France. So again, the policy use here, that would be for the economic accounts, perhaps to complement the new dashboard of indicators of wealth that is used in France. So far, there's only greenhouse gas emissions and change in land use, that are the two environmental indicators. Could contribute to biodiversity resource mobilization efforts. So there's a big gap between what countries have said they would do and the actual amount of finance that they mobilize to protect biodiversity. So that could be an important indicator. Could be used for build a standardized indicator to measure and monitor the achievement of specific policy objectives, which we have looked at as the good ecological status. And then, so it could be used, policy instruments such as taxes and permits could be used also in the policy process in the finance law. So in France, the parliament votes the budget of the nation every year. And as an annex, they already have the required costs to attain the objectives of climate change mitigation. So they could also have, as an annex, the required cost to attain good ecological status, for instance. And these also characterize the residual impacts of marine policy to reach the good ecological status, which is not reached yet, even though it was supposed to be reached in 2020. So what kind of costs can be included? Maintenance costs. So that there's a typology, which is here from Levrel et al. In 2014 on the cost of on maintenance cost for the Marine Strategy Framework Directive. So there's three kinds of costs. There's the cost of monitoring and information, collecting data, doing scientific research. The cost of preventing environmental degradation. That would be to avoid impacts on the marine environment. And then there's the cost of restoration and remediation after impacts occur. What are the methods to estimate those costs? Well, you can use cost transfers. So that is looking at projects or countries that have conducted different kinds of actions and taking the costs that they produced to use in your own setting. You can have a look at the discussion paper 5.1 of the revision of the MAIA to have a deeper understanding there. You have dose response models, such as the one in Balfour et al. 2004 that looked at different characteristics of marine protected areas to estimate how much they cost. So, for instance, the size of those marine protected areas or the distance to the shore. You potentially also have abatement cost functions, such as the famous McKinsey CO2 cost curve, where you look at different actions and how much effective they are at reducing the specific issues that you look at. You also have expert opinion or budgeting. For instance, the Biofin Finance Initiative is looking at how national governments can budget the needs for protection of biodiversity. And then you could have also bottom-up accounting from economic agents. That would be like each economic agent in their institutional sector would report on the cost required to attain a good ecological status. And so there's private accounting approaches like CARE, which has been published by Rambaud and Richard in 2015. There's ongoing work in the ecological accounting chair. So here we apply these approaches on three topics: biodiversity, which actually I'm not going to discuss today because we're still looking at which environmental targets to use. We look at eutrophication and we look at fishing. So these are very first results and first approximations of unpaid ecological costs. First, we take a linear relationship between ecosystem condition and costs. So we want to reach 100% of the good ecological status, and so we look at that. Unpaid ecological costs are yearly expenses, and for these two issues, fishing and eutrophication, we look at monitoring and avoidance costs. We do not look at restoration costs. That's because there's natural regeneration on those issues. If you stop the pressures, then you will go to improve the ecological status. You don't have to do active restoration. So looking at first eutrophication, we take the actual costs paid in the different subregions, and we look at the difference with what would be required, and so that gives us a debt for the monitoring costs of 1,200,000 euros, and for the avoidance prevention costs, a debt of 77,600,000 euros. For fishing, we do the same thing, and we get another debt. This one is larger because there's more fish stocks that are not reaching the maximum sustainable yield. And so what we're going to do next is try to do a more refined marginal approach to estimating fishing unpaid ecological costs. Basically, the the quantity of fishing effort is going to determine the pressure you put on the fish stocks, and so that could be either modified through temporary suspension or definitive outings of fishing vessels. And we have regulatory frameworks to do that. They have the formula for us already, and so we're just working on the explicit link between the outing of vessels and the impact on the fish biomass to calibrate this function. So we're going to focus on other kinds of work on trying to estimate it for biodiversity, and then just a small exercise that we try to do, looking at how unpaid ecological cost would be integrated into national economic accounting. So that's parts of the chapters of the CAIA. But if we start thinking about those and how could the figures that we've produced be applied in that setting. So the main way to look at economic figures in the CAIA is to reveal the value of nature and ecosystem services. And so you have here a new institutional sector, which is ecosystem trustee. Ecosystems are assets, and the production frontier is increased with the ecosystem services. Degradation is defined as the loss of ecosystem services, and it can be then looked at in the fixed capital consumption. And so if you adjust fixed capital consumption, then you can produce degradation adjusted GDP figures. But for our approach, looking at unpaid ecological costs, there's two possible ways to integrate it into the national economic accounting. The first one is with the ecological debts approach from Vanoli, and that's also what's inspired the CAIA chapter 12.3, where there's also a new institutional sector, which is called nature. Ecosystems are also not assets, and the production is not changed. The definition of degradation is biophysical. It's the condition of the ecosystems. And the degradation is a capital transfer, so a debt to nature. So this is just a capital transfer, so there's no possibility to look at degradation adjusted GDP. But in the other possible way is to impute unpaid costs, which is presented in the first version of the CI in 1993, where ecosystems are assets. The degradation is defined as the condition of ecosystems, and it can be calculated into fixed capital consumption. So that then allows you to calculate degradation adjusted GDP. And so in our work, if we sum all the unpaid ecological costs that we calculated in a very rough way, so one way would be to have a transfer of capital from the nature institutional sector of 273 million euros to the sector that is causing the degradation of the ecosystem. And another way would be to add fixed capital consumption of 273 million euros to the sector degrading nature directly, and then you can adjust GDP for this degradation. So if you have any questions, thank you for your attention.
Thank you very much, Adrian, and thank you for sparing us time for the discussion. And now I hand the sharing role to Lisa, because she's taking care of leading the discussion section. So thank you from my side.
Yes, thank you everybody for a great presentation. So yes, there have been a lot of questions on the presentation, so I will start right away. So on the first presentation on the ocean accounts, there was
question by Rob Beren. So there is always a discussion on whether one should or would like to include or exclude the abiotic services, especially offshore oil and gas extraction. Is there a general guidance on whether and when to include or exclude those services? If one looks at the value of natural capital of the marine environment, this value tends to be dominated by oil and gas, although these services are not depending on the status of the marine environment. So this was a question to Michael.
Yeah. Well, I understand the difficulty, but a lot of our purposes in ocean accounting are to feed fairly broad planning and policy processes, and like marine spatial planning. Well, countries that are doing marine spatial planning, if they have access to that information on the abiotic assets and services, then they have a consistent basis for doing their planning and making their decisions. So if you're doing a purely ecological analysis, then it might not be as necessary. But I think in a broad sense, to understand the benefits of the ocean to the economy in general, and to plan for more sustainable use of the ocean, that I would generally include the abiotic assets.
Okay, thank you. Then there was another question by David Barton. So from a policy communication perspective at national level, do you advise including coastal wetlands and coastal terrestrial zone in thematic ocean accounts, or to work on bespoke thematic satellite coastal ecosystem account? And then there's another comment really. At subnational. Okay. Yes, yeah, please continue.
I understand the challenge that the coastal wetlands would also be part of a terrestrial or freshwater account. If ocean accounts were part of a national ecosystem account or national general environmental account, you wouldn't need to make the distinction. But I've seen in some cases where different groups are looking at the coastal areas using different frameworks and different classifications. I guess the basic recommendation is that someone should do it. Generally, that if someone's doing an ocean account in an area and no one has included the coastal wetlands, and there's no ecosystem accounting available for the coastal wetlands, then it would be within the scope. But if there's already a perfectly good ecosystem account for the coastal wetlands, then it wouldn't be necessary to duplicate it. Like a lot of ocean accounting and ecosystem accounting in general is trying to fill in the gaps in our knowledge. So if it's not a gap, I guess it wouldn't need to be filled in.
Yeah. And then there has been like this question, this is from me and Rob both. So what does joining the GOAP require from countries or institutes? So this has been discussed in HELCOM or in the Baltic Marine Environment Commission. So does this require extra resources, or, for example, regular reporting from the members, or?
No, it's a fairly loose membership. You can imagine anything that's run by Australians is fairly informal. But there are no financial or other resource implications. It's simply an opportunity to to get together with like-minded people, I guess. The benefits, though, is that members would be more likely to get support, where we have quite the access to networks of experts who we can call on to deliberate on various issues. So yes, there are very few costs. The terms of reference are on the website there. Yeah, and it's usually easier for research institutes and academic institutes to join than an entire country. We've had some countries deliberating for a couple of years because they have to get it through a fairly extensive bureaucracy to become a member of anything.
Yes.
So, yeah, I encourage looking at the terms of reference there.
Mm. Okay, thank you. Then moving on to the Benting's presentation on the value of deep sea ecosystem restoration, there was a question by Markku that interesting presentation that an MP and good that MPA established for a deep sea coral habitat. But what does that mean in terms of limiting human pressures on the corals? I guess there is no bottom trawling since it is so deep. Litter or sedimentation are impossible to prevent since trash and sediment particles may flow from far away. What is actually banned or limited by the MPA?
Yeah, first thank Marco for this excellent question. Yes, MPA is mainly introduced here for reducing the negative impacts of bottom trawling. And this measure is proposed by my Italian colleague who are working on Don Canyon restoration. And I really need to double check with them about how deep the bottom trawling goes. And another ongoing initiative, the restoration. Yeah, I know that they are trying to put restoration in a larger scope, which means that not only MPA and active restoration activities by artificial reef, but also combining the eutrophication reduction measures, litter cleanup measures, and other measures to reduce various pollution stressors, so that we consider both land sea interactions and also ecosystem-based management, so as to achieve the goal of restoring ecosystem.
And then another question from David Barton. Could protest zero bidders also be due to disagreement with the payment or vehicle institution proposed in the scenario? And I think like Rob Veren's comment kind of are about the same issue about the negative bids and the uncertainty. So
yes, thanks David, thanks Varen for very good questions. And for David's question, and the answer is yes, mostly they rejected to pay because they didn't want to pay additional tax, or they just don't want to pay the tax as a payment form. And in terms of Varen's question, is that let me see. Fortunately we didn't. And the uncertainties. Yes, and in the presentation I presented, the question is asked in a way that the respondent will understand, and they will obtain the restoration benefits without uncertainty. But in a follow-up question in the survey, we did ask the respondent and that when the restoration success is uncertain and the benefits provided will be uncertain, how much willingness to pay how much they would like to pay. So that analysis is not included in the presentation and the paper I referred to, and actually this will be included in another paper.
Okay,
Yeah, and I think Vera also has another question about the negativity. Yeah, this type of negative answer Vera mentioned. Unfortunately, we didn't include it in this questioning survey. So I think it's a very good point. We definitely will need to improve and include this part in the future survey. And as I wrote in the chat, that what we included are the following questions like: I cannot afford to pay, object to paying tax, ecological risk restoration are not important for me, and the government and other bodies should pay out from their current budget, and I don't believe the restoration will actually take place. I don't use the marine environment and other various reasons.
So, Vera, did this answer your questions or comments? You sent quite many comments and questions, so I'm not able to read them all out here. So I guess so. Then there was a comment by Olivier Laroussini. If not a market value, could it be a value for compensation of activities impacting similar ecosystem? I think this was venting also for you.
All right. So, excuse me, could you restate?
If not a market value, could it be a value for compensation of activities impacting similar ecosystem? But I'm not sure what this refers to. So, Olivier, if you are online, maybe you could elaborate a bit. Or...
Right, I could, from my understanding, yes, it's a non-market value. So that means if we manage to establish a kind of payment for environmental services market, then yeah, this value could be kind of traded in the man-made market or artificial generated market.
Mm. Okay, then about Adrian's presentation, I haven't seen any questions on the chat, or am I missing something? Anyway, I have one question about the biophysical accounts. So how do the habitats differ between countries? Is there some type of international classification? Do you know, for example, for the EU level on the?
So we use the UNIS classifications of habitats, which is a European classification.
Okay.
The IUCN one. In France, the French assessment of ecosystems also kind of twisted its own. But I think there's keys to reclassify it between the different possibilities.
Because I see that this work could be used to sort of to create a standard for analysis and like for example, the socioeconomic analysis and reporting required by the MSFD. So in that sense, it would make sense to use some kind of uniform classification for the habitats, but I don't know. So, and
there's also a classification of habitats of community interest in the Natura 2000 policy document.
Okay. And I got a comment from Marco that there's some kind of HELCOM classification that could be used for the Baltic Sea. Then there's a question from venting to Adrian. What are the main challenges when you evaluate the monetary values of ecosystem services?
So we actually don't evaluate the monetary values of ecosystem services. We evaluate the maintenance cost to reach good condition of ecosystems. So we don't even look at the supply and use of ecosystem services from those different marine ecosystems. there's work going on those different issues, but not within the MAIA project.
And I don't know if I got something wrong, but did I understand correctly that the unpaid ecological costs sort of equal the cost of degradation, or that's how you assume it, or?
Yes, that's how we assume it, but it's very different from the value of loss ecosystem services. Doesn't measure the same thing.
Yeah.
And so our first challenge is to define what is a good ecological status, or what are the environmental targets that you want to achieve, because otherwise you cannot look at what is unpaid.
Yeah. But then doesn't that require that then the good environmental state is something that is sort of that everybody agrees on, that it's the state that we want to achieve? I don't know if it is, or
right. So there's in Europe there's the Marine Strategy Framework Directive, which has some agreements on several good ecological status for eutrophication, for fisheries, but then on other dimensions that's either doesn't exist at an international level, or maybe it's not appropriate to use. So we're going to look at biodiversity, because that's a big issue and we don't know what to use. If we can use objectives or targets that are on the state of the environment, or that are more targets on the means that you put into achieving those ends, such as the percentage of your area that is under protection. So that's a big issue.
Okay. Then there are a couple of new questions. So from Vending, if in the accounting region ecosystem deteriorates in some location, can we improve the ecosystem in other locations so that the whole ecosystem service values in the accounting region will be positive?
Well, so the ecosystem service values could be indeed positive, but the ecosystem condition would not. So it depends on your management objectives, but what we do in our approach is not looking at the differences in ecosystem service values. So we couldn't answer this question.
So I just jump in to clarify my question. What I thought is about if we look at one accounting region where there are different grids, right? And maybe in certain grids the ecosystem is deteriorating and the services and the values are decreasing, and in other grids that the ecosystem actually, for example, in the moderate condition, but it's better than what I mentioned in previous grids. So if, for example, if the policymaker is trying to just say that, okay, the goal is to improve the ecosystem in average in the whole accounting region, and aim to keep the ecosystem service values the kind of positive in the whole region, they could actually literally just invest in the grids with a moderate ecosystem, and to boost the ecosystem values, service values, and to compensate the grid loss in other locations. So it's just a thought that it may not actually probably in the end it will not improve the grids where the ecosystem deteriorates the most. But as I agree that it is probably a policy question how detailed the resolution should be to support the policy decision.
Yes, and with the spatially explicit grid, then you can really have a look at either looking at the average, or just for each pixel you want to reach a certain condition.
And then there are one final question. Are policymakers concerned with the uncertainty bounds on the unpaid ecological cost estimate? It depends on whether this estimate is used for awareness raising only or for more specific purposes, such as financing a strategy for actual target achievement. And this was from David Part.
Yeah, I think that's a really good question. And I have to go in more detail into what is the recommendation for the annex of the budget law, because that's obviously a very important piece of information for voting on the budgets. And so there has been a big report on how to calculate that for carbon, looking at the different kinds of technologies to mitigate greenhouse gas emissions. And so I have to look into more detail into what is agreeable in terms of methods and in terms of uncertainty. What we're going to do is propose different scenarios, and we'll see how much the costs differ between the different scenarios.
Okay, thank you. What are the scenarios based on? Sort of, what did you?
So they're going to be based on the expected shape of the relationship between costs and attaining good ecological status. That could be convex or even exponential curve relationship. If we think that it's going to be very, very hard to pay for the last incremental gain in some dimensions like eutrophication, or maybe it's concave. If we think it's a very large cost first, building a plant or something, and then marginally it declines. So there's these kinds of scenarios that we can use. And then on the, yeah, I guess that's it. I don't know, Harold, if you have something else to add.
No, I think that's fine. Thank you. Okay, I think we should have stopped already 10 minutes ago, and I think we should move on to the wrap up and next steps. So I think it's Markku now.
Yeah, okay. On my behalf, thanks for really, really interesting and illustrative presentations. As I said in the beginning of my own presentation, it has been a learning path. The whole MAIA project this far has been very exotic to a marine ecologist like myself, and I think my learning curve has been very steep, and I hope that has been the same for any social and socio-economic researchers involved in the project, and I hope also you guys who haven't been involved in the project have enjoyed the presentations. Just to wrap up, I could say that there was nice presentation by Tinju, who raised many challenges of marine accounting, assessing and valuing the different types of ecosystem services, from regulating to cultural services. Then Elina and me tried to answer some practical challenges, and then Wenting raised the point of potential conflict between two activities, such as harvesting of algae and cod fishery, which highlighted how benefits could be balanced in an optimal way if accounting would be implemented. Then Michael gave a very illustrative presentation and background on the whole history of ecosystem and ocean accounting, how we have progressed from generic EEA concepts to more specific accounting of ocean services. And then again, Wenting on behalf of Eamon O'Connor and Stephen Hines, colleagues from Ireland, showed using a very nice example from Dorn Canyon Naples, how non-market value should be taken into account in accounting. And finally, Adrian gave 2 nice presentations on the progress of marine physical and economic accounts in France, highlighting the linkages of ecosystem accounting with ecosystem conditions and reference levels, and highlighting the various types of costs, and most importantly, pinpointing the large sums involved in the unpaid ecological costs at the range of even hundreds of millions of euros. And I think this point very nicely highlights how important this type of ecosystem accounting work is, how it can be used in policies and to convince decision makers on to do or take measures to safeguard biodiversity and ecosystem services. So thank you very much for Tinju, Wenting, Michael, Adrian, and Lisa for excellent presentations. Adrian and Soile for chairing, and Lisa for facilitating the vivid discussion. If Lars Hen is available still, would you like to give the final words on behalf of the MAIA project, and maybe give your view on the next steps forwards in terms of MAIA, and also maybe more generally in marine accounting?
Thank you, Marco. Yes, that will be my pleasure. So first of all, many thanks to the presenters and also the moderators of this very interesting webinar. I learned a lot of new things. It was really nice to see also the discussions and all the questions asked by the participants. I think one of my main takeaways is that again, this webinar confirms to me that marine ecosystem accounting is maybe more complex than working on terrestrial areas, because of the mobility of fish species, also the complexity of the food chain, and also the need to consider that additional dimension. I think we are making progress in the field, but it also seems that we still have a number of steps to take to really come up with a solid methodology and for marine ecosystem accounting. So on the one hand, it's more work. On the other hand, of course, it's also nice to have further challenges to work on from a technical perspective. And with all the people that are working on this and the Go Up, which I wasn't aware that it was such a large organization already, with so many case studies being conducted. I think, of course, we will be making progress as an ecosystem accounting community in the coming years. From a practical perspective, I think it would be nice if on the MAIA website we could put a link to the background papers that have been prepared and published, because I for sure really would like to read all of them actually, and I'll start with the ones from France. But maybe we can put the links on the website, or even the papers themselves. Let's see. If you are willing to share those papers for the presenters on the MAIA website, please let us know, Nicolas and myself, so we can put a link on the website. I think with that, I would like to close the session today.